Welcome back, ladies and gentlemen, to part 2 of lesson 4-5, subtracting rational numbers. We're looking at the example of part 2, and let's listen to what this gentleman's asking us.
Model each subtraction expression on a number line. Find the value of the expression.
Okay, so ladies and gentlemen, before you begin, please notice that in between each of these integers, this is cut into 6 pieces, which would be the common denominator that we would use. Also, if you look over here, you'll see that this one is broken into 4 sections between each of the integers. And again, that would become the common factor that we would have between these denominators. So go ahead and try working this problem. When you come back, we'll look at the solution and see how you found your answer. Okay, thank you for coming back. We see that the problem initially has us starting at -1/2, which I know is halfway between, or 3 out of the 6 pieces that are located on this. So I'm at -1/2. This is indicating that I'm going to continue moving to the left, and I need to move 5 more pieces since I haven't broken to 6. So I'm going to go 1, 2, 3, 4, 5. That is going to put me at -4 1/3. So that's also, -4 thirds or -1 1/3. The other way we can do that is to find those common denominators and do the math, and we would find that when we do that, we get -8/6, which simplifies to -4 thirds, and if we wanted to change that improper fraction, we're going to get -1 1/3. So let's look at the next one that says we are moving 2 1/4 to the left. So that means I'm going to start here. This means I'm changing directions, and this means I'm going to go the other way, or going where it came from. Or basically, minus a negative is plus a positive, which tells me I'm moving to the right. So I start over here, and since I have a minus a negative, that's going to be changed into a positive sign, and I know I'm moving to the right for a positive sign. So it tells me that I'm going to be needing to move 3 1/2 of those places. So from here to here is 1, here to here is 2, and then here to here is 3, and I need to move half, and since these are cut into 4, that would be 2 of the 4 spaces that I need to move, which is going to place me at 1 1/4. Again, we can make these have like denominators, and we can combine these, and we would find that a -2 1/4 plus a 3 2/4 is going to equal 1 1/4. Okay, so hopefully if you need to stop and rewind this video any to catch down these notes, you'll do that. We're going to continue on to the next piece. Okay.
Which number line model represents the subtraction expression 1 3/4 minus -3/8?
Okay, so ladies and gentlemen, which one of these two? So where do we think we're going to start? Right, they both start in the same place, so we kind of knew that, right? We're starting at the 1 3/8 place. So we're starting at the same place, but this is minus a negative. What is that the same as? Correct, adding. And so that means we're going to continue to the right, correct? So our answer is going to be B. Okay, let's go to part 3. Remember, if you need a pause to take these notes, please do.
By mixing these secret ingredients, I'll create a solution which I can spray into the atmosphere, creating superstorms wherever I want. First, I'll control the weather, then I'll control the world. Foiled again! Igor, come quickly and bring me a sweater.
Carbon dioxide and nitrogen are 2 gases found in air. Both gases can be used as coolants in solid or liquid form. Carbon dioxide becomes dry ice at -78 5/10 degrees Celsius. Nitrogen becomes liquid nitrogen at -195 7/900 degrees Celsius. Which of these temperatures is higher? How much higher?
So ladies and gentlemen, we need to make the no-need plan. You can do it horizontal, or you can do like I often do in class and make it a vertical. Either way is just fine, just whatever works for you. And what do we know? Well, we know carbon dioxide is at negative 78.5 degrees Celsius, and we know nitrogen is 195 degrees 0.79 hundredths negative degrees Celsius. So which of these temperatures is higher and how much higher? So what we need to do is to find out which one's higher, which one's higher, then which one has the greatest is high. By how much higher is it? So we're going to be looking for a difference. So we need to find out the difference between them. So how are you going to do this? Take a moment and work this problem out. Go ahead and pause the video. Okay, so ladies and gentlemen, when we come back, well, just came back, sorry. What do we know? Well, we know the two negative temperatures that I spoke of, the negative 78.5 degrees, as well as the negative 195.79 degrees. What did we need to do? We need to find out how much higher the one temperature is, so we can use the temperature's position on a number line to identify which one is higher than the other, and we can subtract the lesser number from the greater. So we're going to identify. So if you're using a number line, just like we see on the thermometer, we can easily see which one's higher. So by this, we know that negative 78.5 degrees is actually warmer or higher than the negative 195.79 hundredths degrees of Celsius. So one, that's a visual way of seeing that, which helps us greatly. And then we needed to set this up. So we needed to subtract the smallest one from the larger one. So what we're doing is minus a negative, so we're going to rewrite that as a positive. And as we're doing this, we see we have one negative value and one positive value. So which sign am I going to keep? Well, I don't know yet. So I need to take the absolute value, and whichever one is larger is the sign we keep. Since the absolute value of negative 195.79 is greater than the absolute value of negative 78.5, we're going to keep the positive sign. So now I have 195.79 minus 78.5, and I'm going to get a positive 117.29. Now I can rewrite it just like this as down here, and I'm still going to get the exact same answer. Okay, thank you very much. Let's see if we have one more piece to watch.
The temperature at which a liquid turns to gas is its boiling point. The temperature at which a liquid turns to a solid is its freezing point. Liquid nitrogen's boiling point is negative 195 and 79 hundredths degrees Celsius. Liquid nitrogen's freezing point is negative 210 degrees Celsius. What is negative 210 minus negative 195 and 79 hundredths? What does this difference mean?
Okay, so ladies and gentlemen, one real quick thing. If its boiling point is negative 195.79 degrees Celsius, then that'd be why we see it as a gas, because we are above 0 degrees Celsius. So we always see nitrogen as a gas naturally occurring in our atmosphere. Okay, so what is this difference and what does it mean? Go ahead and try working that out. Pause the video. Okay, thank you for coming back. You can see again the number line is helping us to see which one's lower and which one's higher. As we expected, the freezing point should be lower than the boiling point. And we do mathematically, so compare the math to what you have written. For those of you who like to say, I don't know what to show, I just do it in my head, or I just use the calculator, look at all these beautiful steps that are being shown. Go ahead and copy those down so you know how to model things when I'm asking you to show work. Okay, so we find that we look at the difference of the negative 210 degrees with the 195.79 degrees, that we have a negative 14 and 21 degrees, 0.21 degrees difference. This just means that's the amount of difference between the boiling and the freezing point. Thank you very much. Go back through your notes, check for any questions you may still have, watch the video for further clarification, and rewatch the video for further clarification, and bring those questions to class. Thank you.